Good morning, Cappuccino. It is Tuesday, May 12th, and this is our warm-up for today. So first 5 people who get it correct get 5 points extra credit. Find the sum of the first 10 terms of the sequence. Here is my sequence. So a little hint, you got to figure out what kind of a sequence it is so that you can figure out which formula you need to use. Okay? So try and do it with the formula. You can also sort of just grind it out, I suppose, as well. But try and use the formula. So use your formula packet. Get your formula packet out or your notes. But I like, using the formula packet because it's all in one easy place. All right. Second question, find the value of the common ratio if the first term is 11 and the sum of the first 12 terms is 2,922,920. Okay, this problem is quite a bit harder, and my hint on this one is use your graphing display calculator. Okay, that's the big hint on that. All right, so for those of you who don't know if you got it right yet, here is the warm-up, the last warm-up from last week. There is a flu epidemic in Cozy Town. Yes, there really are. All of these problems are in our textbooks, in math textbooks. So this whole COVID-19, people have been thinking about this for a long time, doing math with it forever. On the first day, 2 people have the flu. On the second day, 10 people have the flu. On the third day, 50 people have the flu. Show that the number of people with the flu forms the first 3 terms in geometric sequence. Okay, 2, 10, 50. Geometric means that you have a common ratio. You multiply to get the next term. So if I was adding, this would be plus 8, but this is not plus 8 from 10 to 50. So we know it's not arithmetic because I'm not adding the same amount each time. So what is my common ratio? What am I multiplying by? So this one's pretty easy. We can just look and we can tell that R is equal to 5. So it's being multiplied. So 2 times R is equal to 10. If we solve for R, we get 5. And likewise, 10 times R is equal to 50, and if we solve for R, we get 5. So we do have a common ratio, so therefore it's a geometric sequence. Okay, you could have very simply just have gone like so, times 5 times 5. Okay, that would have also qualified for proving to me that it's a geometric sequence because I can see that you have a common ratio. All right, calculate how many people have the flu after 1 week, after 7 days. All right, let's get our handy-dandy formula. If I want to know a certain term, in this case the 7th term, I'm going to use this formula right here. So the number of people on the 7th day is going to be equal to U sub 1 times the common ratio to the 7 minus 1. All right, so what is the first day? U sub 1 is the first day, that was 2, times the common ratio we know is 5, and then n is 7, 7 minus 1 is 6. And again, we want to use our calculator for these problems. These numbers are all way too big. So I'm going to do 2 times 5 to the 6th power. And I get 31,250. So in just 1 week, we could jump up to that. Oh my gosh. Okay, so that's every 2 people. Every person is infecting 5 people. Okay. Use your model to calculate how many people will have the flu after 1 year. Okay, so same idea. U sub, there's 365 days in a year, is equal to U sub 1 was 2 times 5 to the 365 minus 1 would be 364. Okay, and we're not going to worry about whether it's a leap year or not, because check out what happens when I put this into my calculator. 2 times 5 raised to the 364. My calculator can't even give me a number that big. It's so huge. Okay, so I know some people who actually found the answer. They did it by using Google Calculator, whatever that is. But this is like some really huge number. It's so big that it's overflowing my calculator's capacity. What if I did just like 100 days? So let's clear that. If instead of 364, say 100 days, what would that be? So check that out. That's just 100 days. 1.57 times 10 to the 70 times 10 to the 70. Okay, that's just 100 days. So this is an amazingly huge number. This is all that my calculator can do. I can't really simplify this on my calculator, but by putting in a smaller exponent, I can get kind of an idea of how big this number is going to be. 1.6 times 10 to the 70. Okay, that's what this E70 means. That means times 10 to the 70th. So I would have to move this decimal place over to the right 70 times. And that was only 5 to the 100th. All right, so why is this not reasonable? This is not reasonable because this number is way too big. This is a huge number. So what is the population of the Earth? It's about 8 billion. 8 billion would look like this. If we were to write that in scientific notation, that's 8 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the 9th. Okay? Remember, this was 10 to the 70th. By the way, if this was on a calculator, this would be 8E9. That's what that would look like on a calculator, 8E9. When you're writing answers that are really, really big or really, really small, you do not use calculator notation. Do not write it like this. You need to change that e to the 9th to times 10 to the 9th. Okay, so why is this not reasonable? Well, it would be more than the population of the Earth. Okay, and if you've been paying attention to the news, they talk about something called herd immunity. Once 70% of the population gets a virus, it's really hard for that virus to continue to spread because people who've already had the virus tend to be immune to it, and so therefore they can't get reinfected. So you might have people who are protected because they're surrounded by people who've already had the virus and they can't pass it to them. So basically, the biggest number we would say that you could get would be 70% of 8 billion. You know, given that the population of the Earth is around 8 billion right now. The highest number you could infect would probably be about 70% of that. So if we did 70%, 0.7 times 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be that. So 5.6 billion would probably be the most people that you could infect with the virus because it would be too hard for the virus to find those other people who are hiding amongst people who have already been exposed and have antibodies to the virus. Okay, so herd immunity and the fact that there's only 8 billion people on the Earth. That's your answers to Part C. All right, so good luck with today's warm-up. And my notes and the assignment are going to be coming up a little bit late today because I've got some things I have to do this morning, and it took me like 2 hours to pick my warm-up today because there's some really hard problems I could have given you, and I was trying not to be too mean. All right, I will stay tuned. Sorry, you stay tuned for the next video. It'll be coming up probably in a couple of hours. All right, take care. Bye-bye.